So today I'm going to talk about D3 and using data tables. So when you use D3, you see like, oh wow, this really cool stuff, but it gets a little bit complicated. But the most basic thing is data. Like, what is the structure of the data? So a good place to start with D3 is if you scroll down on the examples page to the basic charts. Here it is, basic charts. Like a line chart and a bar chart. So here's the bar chart. And you see what it's doing, including the D3 library, has a bunch of D3 code that like uses D3 conventions. And then it loads a data file, like d3.tsv. So d3.tsv means, TSV means tab separated value. This is really nice documentation. So if you see d3 anything, you can find out what it means in the D3 documentation, which is really nice. Usually you can just Google for it and it will come up as the D3 documentation. So TSV is really a variation of CSV, where the delimiter is tabs instead of commas. CSV means comma separated value. So the way it works is you call d3.csv, give it a URL, give it a function that gets called on each of the objects, and then a callback to call like once it's done, once it has the file. And then there's d3.csv.parse, which just parses a CSV string. So let me kind of show you what that is. So JSBin is a nice thing. You can edit code right in the browser. So you can add the D3 library, which will add it as a script tag here. And then you can start writing JavaScript. So you can open up the open up the developer console to see the output when we start printing things. Tools, more tools. JavaScript console. Then it will pop up this thing. So if we type here console.log hello, we get that here. So let's say we have some CSV data. This is how in JavaScript var means variable, so you can make a variable. You can click this HTML thing to show and hide the HTML. So we're making a variable called CSV string. String means it's a data type that's a sequence of characters inside of quotes. That's what a string is. So a CSV string is the first row is the header names, and then the other rows are like the values for the data table. So as an example, let's look at the iris dataset. The iris dataset is a really famous dataset used for machine learning, and it's really simple. And this is what it looks like. Each entry is a flower and has like sepal length, sepal width. These are like different aspects of the flower, and then the species that it is. So there's this UCI machine learning repository where it has the iris dataset as a CSV file. Iris.data. So I'll just take like the first few lines of this and copy it over to here into the string. So with JavaScript, it's a little tricky to have multi-line strings. You need \n after each line. This is the new line character. So when you read a CSV file, it has these new line characters in the file. And then you need a backslash at the end of each line to tell JavaScript that it's a multi-line string. So now JavaScript knows that like here's the begin quote, here's the end quote, and this whole thing is a big string. So now if we type console.log, before we did this. Hello, we just passed a string into that function. So console.log is built into the browser, and you can give it a string, and it will print out the string here. So if instead of the string literal hello, which is in quotes, if instead we type CSV string, it will print out that string. See, this is the variable name, so we use the variable name to print out that string. So this is just the data, but CSV files, usually the first row is the names of the columns. So in this website, there's iris.names that tells you what the columns are. And these are basically the columns. So I'm going to paste it in here and just sort of separate out the column names. So sepal length, sepal width, petal length, and then class. And this will be the first line of the string. So this is called the header of the CSV file, which is the column names, and then this is like the data, the rows of the table. So here we have a complete CSV data table represented in JavaScript. So now we have our CSV string. So we can use this function d3.csv.parse. So if we say var data equals d3.csv.parse and then give it this CSV string, it will assign the variable data to be an array of objects parsed from the string. So if we console.log the data, we can actually see the structure. I'll make this bigger. So when you call console.log and pass it a data structure, like an array, it represents an array with these square brackets, left and right. So here's an array with 1, 2, 3, 4, 5, 6 objects in it. One object for each line of the file. And you see the first object has as a key the string petal length, and as a value the string 1.4. So it has this same structure for each of the entries in the data table. But this has a few problems, right? So this is the basic representation of data with D3. In a table parsed from CSV gets transformed into an array of objects. Each object, the keys are the column names, and the values are the values from the table. But this has a few issues, like there's an extra space right here. So this comes from just how D3 parses CSVs. So it comes from this space right here. So there needs to be no space between the column names. So after I remove those spaces, we scroll down to the latest version, we can see that this is more correct. So it's just using these as the keys, the column names. So this is what d3.csv.parse does, but how does that actually work? Like, what is it really doing? I want to just kind of explain in detail how that works. This is just one way you could do it. So let's say you wanted to parse the CSV string yourself. So I'm going to make a function called parse CSV that parses a CSV string. So it takes as input a CSV string and gives as output a data table. So let's say var data equals an empty array and then return data. So this is like the outline of our function, right? So the way we might use this function is say like var, I'm going to use a different term from data just to make the code clear, like parsed data, parsed CSV, parse CSV, this CSV string. So I'll say this is iris CSV string. So let's put the function first to say that like this is the main thing, and then this is the program that uses that function. So we can then log the result, and we can see that right now it's just an empty array with nothing in it, an array of 0 elements. Let's say we wanted to write a function that has the same functionality as d3.parseCSV. So strings in JavaScript have a function called split. Let's say you have a string like a comma b. You can call, let's say we have a variable str, that's this string, a comma b, and then we can call str.split and give it a comma. And then that will give us an array of each of the strings split by this comma, which is called a delimiter. That's what the term delimiter means. So, like, let's say we had a string that was separated by a new line, like a line break. Here we can say str.split and give it a new line, and it will give us a comma b. So the first thing we need to do to start parsing a CSV string is to split it by lines. So we have an array of each line. So we can say var lines equals CSV string.split by new line. And then let's say we could just return the lines just so we can see it as the output. So now the thing that's returned by the function is an array of each line, where this is the first line, this is the second line, and this is the third line, and so on and so on. Now we have split the CSV file by lines. And we can use the first line as the keys for the objects, and then the rest of the line should be the values for the objects. So once we have the first line, we can say make another variable for the header or column names. Let's say yeah, column names. Lines at 0, which will give us the first line, dot split, and give it a comma. So now if we return this from the function, we can see that this is the value that it gets. Sepal length, sepal width, petal length, and class. So these are the keys for, the keys that will be on the objects that are returned by the function. So what we want to do is we want to have a variation on lines that doesn't include the first row. So the way we can do that in JavaScript is like we can remove one element from an array. So let's just figure out how to do that. So like var array is 1, 2, 3, and what we want to do is get an array that just has 2 and 3 and not 1, because 1 would be like the headers, the column names, but we just want all the data values to iterate over that and create an object for each entry later. So we have this array, and I think there's a something called slice, or let's just look it up real quick. So when you want to do something, it's easy to just Google things for JavaScript because it's such a popular language. And W3 Schools, it doesn't really give you that much, usually just a minimal example, but developer.mozilla.org has really good documentation for JavaScript. So I think slice is what we want. Yeah, it returns a copy of a portion of the array. So you give it an argument of begin, which is like where to start the copying from. So let's say array.slice at 1. It just gives us 2 and 3. That's exactly what we want. And then does that change the original array? No, it makes a new array. So really what we want is another variable called like rows, the data rows, which will be lines.slice, or was it splice? Yeah, slice. And the argument is 1 to start at that index of the array, to exclude the first one and just get the rest. So if we return rows from this function now, it should be printed out as this is it. So this is the value of rows here, which is exactly right. It doesn't contain the first row, it just contains all the other rows. So what we want to do now is, to get the data, we want to apply a function to each row. And the way to do that in JavaScript is you could say data equals rows.map. So map is a functional programming primitive that works on arrays. Map takes as an argument a function that gets applied to each element of the array. So the function takes as input one row, and whatever gets returned gets added to this array. So if we just return row, so the function doesn't do anything, it just takes as input something and then returns exactly that same thing. And then we can run that. I'll just clear the console to empty it out. So if we run this again, this is what we get. It's applied to each element of the array. It just returns all the original rows. So if I just return a string like foo, then this map applies this function, which takes as input a row, and for whatever value it is, it just returns foo. So we just get an array foo, 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 like that. So what we want to do is, for each, so we have rows. For each one of these rows, what we want to do is first split it by comma to get each individual value. And then we want to match up the column names to these values. So let's say entries is going to be the array of these values. So let's say var entries equals row.split. And this time we're splitting on commas. So if we return entries from this function, we see now this function is returning an array of arrays. Each array has the values for each row. But what we want, instead of 0, 1, 2, we want this to be the column names. So if we return from this function the column names, then we see that we get an array where each array just has the column names, right? So somehow we need to merge the entries and the column names to create an object. So what I'm going to do is create an empty object. Let's say row object. As an empty object, right? And then we can return this function. We can return this from the function, and then we'll get an array of objects, which is kind of the data structure that we want, but each object is empty, right? So what we want is the keys of the object should be the column names, and the values should be from this entries array. So what we can do is we can iterate over each of the column names, and then for each of those column names we can set up that key value mapping. So one way to iterate over the column names is to use for each. And for each is another functional primitive in JavaScript that applies a function to each thing in here, but it doesn't return anything. It just executes the function. So we have a function that takes as input one column name. So for each column name, what we want to do is use that column name as a key and then get the value from the entries array for that column name. So one nice thing about for each is this function takes as input each column, but it also takes as input another argument, I, the index. So just to get an idea of what these values are, we can use console.log just to show us these values. So this is what the values look like. So console.log column name. Column name is, for example, sepal length, and then I is, for example, 0. So 0 is the index in the entries array that we need to access. So let's just change this I to, instead of just I, get the ith entry from the entries array. So the new values look like this, which is pretty close to what we want. Like the sepal length is 4.7 and the sepal width is 3.2. Now we just need to make this into an object. So the way we can do that, well, first of all, we need to understand like how to assign objects values. So let's make a simple example. Here's an empty object. Var object equals an empty object. So one way to assign values is to put it inside the object. Like let's say x is 5. And then if we inspect this object, then we get this object, x is 5. And then let's say we wanted to add another property to this, like y. We can also say object dot y equals 10. So this will make a new property on the object called y, also called a key. So this is a key, this is a value, this is a key, this is a value in object language. So now if we look at the object again, it has x and y. But there's some cases where you don't know exactly the property name, but you might have the property name like in a variable or something, so you can use this other notation. So object at z equals, let's say, 15. So this will do the exact same thing as this. It just uses a different notation. So it will create another property z and set it to 15. So if we look at the object again, it has x, y, and z. But let's say this property name is in a variable, like var property equals, oh no, I reached the end of the alphabet, like let's say w. Then we can say object at property equals 500. And depending on the value of property, that's what the property name will be. So now if we look at this object one more time, we see that w gets 500. That's because property was w, and then the value was 500. So we can use this syntax to construct our object. So our object is here row object. So we could say row object at the key. The key will be the column name, the property name, and then the value is entries at I of the row. So now when we inspect what we have, we actually have an array of objects, and this is exactly right. This is totally perfect. But class shouldn't be 0.2. Class should be something else. class should be Iris Setosa. Now what's wrong here? So let me just comment this out. And let's see what we have for column names. Column names is sepal length, sepal width, petal length, and class. So it's sepal length, sepal width, petal length, petal width. Oh yeah, I'm missing petal width. Yeah. Okay, that looks better. That looks better. Great, so this is a parsed CSV file. I just want to add a few more things. So like this var, having var. One pattern that I like to use in JavaScript is the single var pattern. So rather than having a bunch of different var expressions, you can have one var expression and you can separate it by a comma. So here's everything separated with commas. And now the indentation looks a little weird. So I can indent this and then return the data. So here we have data and then we're just returning it. So really we can just return this expression here. And we don't need the data variable at all. So this is more like what the function should look like. And here again we can also have the single var pattern. So there we go. There's a function that parses CSV. Let's go back to the D3 CSV parse thing. There's a second argument called accessor, and I'm going to explain what this is used for. So let me go back to using csv.parse rather than our parse function. Alright, so now it's using, uh-oh, there's an error. Why is there an error? Dun, dun, dun. I must have messed up somewhere. Oh yeah, here it needs to be a semicolon. Okay, now everything's fine. Alright, so if we use d3.csv.parse, we get exactly the same results. So d3.csv.parse is pretty much this code, maybe a little bit different. But here's the big problem, is that these are strings, you know? So if we try to treat them like numbers, we're going to have some issues. Like, for example, if you take 1.5, if you take 1.5 and add it to like 0.2, this is what you get. It takes 1.5 and then 0.2 as strings. But what we really want is to parse these as numbers, as floating point numbers, not integers, because they could be 1.5, not just 1, 2, 3. So there's a built-in function in JavaScript called parse float. So if we call parse, well, if we call parse float on one of these things, you see it gives us a number. There's no quotes anymore. So it means we can do things like add them together, and it adds numbers. So this is parsing a string into a number. And we need to do that for the CSV file for all of these fields except for the class, because class is a string. This makes sense to have it as a string, but all these should be parsed as floats, with parse float. So back to this. So when you parse the CSV, you give it the CSV string, and then this bracket notation means the second argument of the function is optional, like we don't need to specify it, but if we do, it will be used. An accessor, which is a function that gets applied for each row. So if I add a second argument here, the function takes as input a row object, and then should return something. One common way of using this is just to change the row object and return the row object. So I'm going to do that, return the row object. So let's take the example of petal length. So we can parse this into a number by saying row object dot petal length. Well, we can't really use this notation because there's a space. It needs to be in quotes because of the space. So that means we actually need to use this other notation, like this. That's one disadvantage of using spaces, but this will work. Row object, so this value, 1.5 as a string, we should access it, but then call parse float on this thing. So now, if we look at the newest value in one of the objects, we can see that? It's no longer a string, but it's a number. So that's really nice. This is parsing numbers. So we can do that for all the rows, but I want to show you that instead of using parse float, we can actually use a shorthand that you see in D3 code a lot. That's just plus, which is a little confusing if you've never seen it, but this just means it does the same thing as parse float. So if we see the latest value, it works. I don't know why exactly this works. I think it's like in JavaScript, if you have 5 and you just say plus 5, it converts it to a number. I don't know why exactly, but like it just works. So you see this kind of syntax in JavaScript a lot. So to parse the whole file correctly, we can copy and paste this line and just change the properties. So we did petal length. Let's do petal width. And now that we have length and width, we can copy that combination and then change petal to sepal for these second two. And I hope I don't have any mistakes. So now, there we go. We have our parsed CSV file. Totally correctly parsed. So this is using d3.csv.parse. Let's say that we wanted to extend our parse CSV function to do that, just to see how it works, just to see how this might be implemented. So in D3 they called it accessor, the accessor function, the function that accesses the data. So we can use that same name. And then we have our row object. So we can just, instead of returning the row object, we can return the accessor function of the row object. Just like that. Call the function with the row object, and whatever gets returned from the function, we return for each row. So let's see, did that work? Oh, looks like that worked. But let's say we did not specify the accessor function. I'm just going to remove it temporarily, If we don't specify that, then what happens? Our code breaks because it's not specified. So the way we can deal with optional arguments in functions, which is very common in JavaScript, is we can say if there's no accessor. So this is like if there is an accessor, this is what it would look like, but exclamation point is negation. So if there's no accessor function, then accessor equals just a function that doesn't do anything. So then we won't need to change this code down here. D is conventionally used in D3 code to refer to like the data element. And this is called the identity function in functional programming. But see, now it works. It parses the file. It just doesn't use that accessor function. So if I put that accessor function back in, it should still work. Yeah, now it does work. So this is one way of doing it. I mean, there's so many ways you could do it, but one shorthand for this would be looking like this. Accessor equals accessor or this function. So this syntax means or, like as in booleans. You have true or true, gives you true, true or false, gives you true, because if one or the other is true, then it will be true. Only if it's false or false, then it gives you false. But in JavaScript, you can use this to conditionally execute certain things. So like if accessor is not defined, then this will run. But if accessor is defined, then it will just assign it to itself, which really won't have any effect. So this is a common syntax you'll see for optional arguments to functions. So this is basically how you can implement D3.CSV.parse for parsing the iris dataset. So I hope you enjoyed this D3 mini tutorial. Come back for more.